Here we are going to develop the generic formula for the distance between 2 points. And to do that, we will first look at an example. So get these 2 points plotted, -4, 1 and 5, 6, and create a right triangle out of them. So now what we're going to look at is count the boxes on the vertical side here. We got 5 units there. And on the X side, if you count those out, there are 9 units. And the distance over here is unknown, so we're just going to call that D. So we do have a right triangle, so we can apply the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. A and b are the legs of the right triangle that create the 90 degrees. And the c is the hypotenuse, which is the diagonal. And in this context, the hypotenuse will be letter D instead of C. So using our values, we have 9 squared plus 5 squared equals D squared. 81 plus 25 equals D squared. 106 equals D squared. And to solve for D, we would square root both sides. So D is equal to square root of 106, which is approximately 10.3 units. So that is the distance between the 2 points. Let's go back and take a look where the 5 came from without counting boxes. Came from the y value, which was 6, minus the y value down here, which was 1. The 9 came from the x value over here, which was 5, minus the x value over here, -4. 5 minus -4 gives you the 9. So let's come down below, and we're going to plot 2 points, but it doesn't really matter where they are. They are just going to be generic points. But if you want to put them where I did, you come up top here and go over 3 units. And this one is -3, 2. And we're going to create a right triangle out of these again. So here we have the points plotted with a right triangle. And we're going to label these points generically. So the point up top is going to be point 2. So x sub 2, comma, y sub 2. The point down below will be point 1, x sub 1, comma, y sub 1, very similar to slope. So next we are going to look at this y direction in generic terms. We talked about how it ended up being the difference in the y values, y sub 2 minus y sub 1. And the difference, the number of spaces here is the difference between the x values, which would be x sub 2 minus x sub 1. So down below here, we're going to pull out this triangle. So draw yourself this right triangle. And on the y side, we're going to put y sub 2 minus y sub 1. That's the height. And on the x side, x sub 2 minus x sub 1. That's the distance this direction. And on the diagonal, we will put D for distance. So we are going to apply Pythagorean theorem again. A squared plus b squared equals c squared. The a and the b are the legs of the triangle, which we have expressions for. So we have the x side squared plus the y side squared equals the hypotenuse, in this case d squared. So to solve this for d, because we're trying to solve for the distance, we have to square root both sides. So here we square rooted both sides, which leaves us with d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. This is the general formula for how to find the distance between any 2 points. We're going to go through 2 examples of finding the distance between 2 points using just the formula. So go ahead and label these point 1, x sub 1, y sub 1, x sub 2, y sub 2. And I am going to write the distance formula out. So make sure you write this out correctly. D equals the square root of x sub 2 minus x sub 1 whole thing squared. plus y sub 2 minus y sub 1 whole thing squared. And we are simply going to substitute our values in. So x sub 2 is 3, and we are going to subtract x sub 1 minus 1. 3 minus negative 1. And the whole thing has to be squared, so I am using a square bracket here to offset the parenthesis on the inside with the squared there. Plus the y sub 2 value is negative 2 minus 4. Whole entire value squared. So now we just have to evaluate this. So 3 minus negative 1 is 4 squared plus negative 6 squared. So d equals 16 plus 36, which is 52. So you will be asked for the exact value as well as the approximate value. Square root of 52 is the exact value, but it is not a perfect square root number, and we can break it down. 52 will divide by 4, so we will simplify this radical. 52 divided by 4 is 13, so we end up with 2 square root of 13 units because there was no label, or the approximate value would be 7.21. Moving on to problem 2, label the points again, x sub 1, y1, x sub 2, and y2. And we'll start applying the formula with some radical values. So please follow along carefully here. D equals x sub 2 is negative 3 minus 2 radical 3 entire quantity squared plus y sub 2 is 5 square root of 6 minus square root of 6 entire quantity squared. Negative radical 3 with negative 2 radical 3, you're combining like terms there, so it's a negative 1 and a negative 2. Negative 3 radical 3 squared still. 5 radical 6 minus 1 radical 6, 4 radical 6 squared. So now to square this value underneath, come over to the side here if you're not sure how this works out. What this means to do is the negative 3 gets squared and the radical 3 gets squared. Negative 3 squared is 9. When we square this radical here, it means we're multiplying it by itself. So 3 times 3 is 9, and the square root of 9 is 3. And remember, if we have something squared and then we square root it, we get the number that we started with underneath, which is 3. So we have 9 here, 3 here, 27 is what goes in this first answer for the distance. And the same thing happens here. We're squaring a product. So 4 squared is 16. The radical squared will just give us 6. 16 times 6 is 96. Doing the addition here, the distance equals square root of 123 units, or approximately 11.09. On the next page in the handout, we are going to use the Pythagorean theorem to develop the equation of a circle. To get started on this, I've plotted this point here. If you want to follow that, 1, 2, 3, 4, and up 3. So plot a point there, create a right triangle, and label this x and then this as y. The hypotenuse here, instead of calling it c, which is in the formula, or d, which is the distance between 2 points, we are going to call it r for the radius of a circle. So we have r here, and I'll explain that a little bit more after we sketch the rest of this problem out. So what we are going to do now is take this point and reflect it over here, reflect it down here, and then do a reflection from up here down to here. So we have 4, 3. We are going to go left 4, up 3. Over here, we're going to come over 4, down 3. And here we'll come left 4, down 3. So make sure you have these other points in the same respective positions, basically reflections of this point. And we are going to use these points to create a circle. So we are saying that the center of the circle is right here at the origin. This is the radius of the circle. So if we take this and create ourselves a circle, it would be somewhere like this. If we start trying to sketch our circle from here and come around and catch this point here, how high up does this come? I am going to tell you, and I'll explain it a little later, that it is 1, 2, 3, 4, it's 5 units up. So plot that, and then come out here and plot it at 5, -5, and down here 5, and then out here 5. Those are the points we will use to connect our circle. And the program I'm using, the circle, is going to be not the best. So I'm going to start right here at our point. I'm going to start around to right here at our point. So there's our circle. And the thing to notice is that this is our origin, the center of the circle, and the radius is r. So everywhere we go, this distance here to the center out is r. And I'm going to draw some more triangles in here to show that. So using this point out here, and we draw the right triangle for that, we come out, then straight down. And the same thing for this point, we're going to come out with the radius, and then straight up. I'm sorry I can't draw the straightest of lines on here. So here is the right triangle involving the point out here, out and then up. And then this one starting here going out to the point and up. Now let's look at one of the triangles here. The first one, x, y, r. We have a right triangle, so we can apply the Pythagorean theorem. X squared plus y squared equals r squared. This same formula for the Pythagorean theorem would work for this triangle, this one, and this one. Even with negative values in there, when you square them, you will get positives every time. So this is the most basic form for the equation of a circle. It's called the standard form of a circle with center at the origin and radius r. Standard form of a circle with center at the origin and radius r. So let's take a look at the graph to the right, and graph x squared plus y squared equals 25. Because you have x squared plus y squared, that means you have a circle. The 25 is the radius squared. So we know that the radius is just 5. So the 25 is equal to the radius squared, which is your hypotenuse squared. It's 25, so r is the square root of 25, which is 5. And the center is right at the origin. So we can plot this information, and that is enough to sketch our circle. With the radius being 5, I would come out here on the x-axis and put a point at 5. We'll come up here on the y-axis and put a point at 5, out this way at -5, down here at -5. And let's label our x and y axes as well. So here we have radius 5 from the center, 5 up, 5 left, 5 down, and we will just connect these 4 points to create our circle. So here's my circle. And I do want to sketch in the reference right triangle. So if we take our right triangle that we had earlier, which was 1, 2, 3, 4, 1, 2, up 3, so that's 4, 3. And if you apply the Pythagorean theorem, you have 16 plus 9, which is 25, that would make this radius be 5. So that's how I knew that earlier. So last thing to talk about this circle is that circles are not functions. Remember that if you draw a vertical line and it passes twice, it is not a function. So that happens here. They fail vertical line test. But they have all three types of symmetry. You have x-axis reflection, y-axis reflection, and through the origin as well. So using the next graph down on that same page, we are going to work on some more stuff with the circles. And to get started, I would plot this point here, -1 up 5, and -3 up 2 for this one. Now, when you get those plotted, we are not going to label them with actual numbers. Right now, we're going to look at these as just generic points. So this upper point is xy, and I'm going to refer to that as point number 2. This lower point is going to be called hk, and that's point number 1, which will be the center of a circle that we are going to draw. So, having this be the center, the fixed point, and this the radius, you're going to take this point out here and create a circle using that as the approximate radius, here out everywhere. Do the best that you can, but that's our approximate circle. So the center of this circle is a generic point, hk. It could be over here, down here, or over here. So the values of h and k could be negative. The radius is r, so that's the distance from the center out to the edge. So again, I am going to draw that in. So here, the distance from the center to the edge is r. So we are dealing again with a right triangle in here. This here, up, and the radius is r, and a circle. So we are going to start with our distance formula again. Our distance formula between these 2 points. So we are going to use the distance formula again. And in place of the distance between these 2 points, we will use r again. And for point 2, I'm just calling it generic xy. So this would be an x here. Point 1 is hk. So the h is the other x value. So this inside here will be x minus h squared. And this one will be, the subtracting of the y values will be the second point. So the upper here, the y, minus the y value here, k. So this will be x minus h squared plus y minus k squared. This right here really is the important part of understanding where the other equation of a circle is going to come from. We're working with a circle that's not centered at the origin. The center is a generic point, which is not called xy. We're using h and k. So the y minus the k, the x minus the h as the values in here. So we have our radius. And to make this fit the other form of a circle where we have x squared plus y squared equals r squared, we're looking to square the r, which would remove the radical on this side. So we are going to square both sides of this problem, and it will remove the radical. I know it's a little hard to see over on the right edge of the screen, but here we're squaring the left side and putting the whole entire right side in parentheses and squaring that out here as well. So r squared equals, the squaring and the square root cancel each other out, and you get the underneath part. So r squared equals x minus h squared plus y minus k squared. This is the standard form of a circle with radius r, but the center is at hk. Okay, so the last page I will go over 2 examples of circles that are not centered at the origin. So the first one here, you've got x squared plus y squared. That is what indicates you have a circle. So here's the formula we just developed on the other page. X minus h squared plus y minus k squared equals r squared. This is showing that the r squared is equal to 9. So we will have 3 for the radius. And the center, remember, is hk. The quickest way to find the center is the h value will be the opposite of what's in here. Because if we just put a 2 right here, we'll get minus 2. And here, y minus k, in order for minus k to become positive, k has to originally be negative 4. So our center is going to be 2 comma negative 4. I'm going to show you a mathematical way of finding that. What we will do is we will take the formula x minus h and set it equal to x minus 2. So here we have x minus h equals x minus 2. Solving this, we would subtract x, so they cancel out. Negative h equals negative 2, so h equals positive 2, which is the opposite sign of what is here. And the same thing will happen over here, but I'll show that equation out as well. So y minus k equals y plus 4. Subtracting the y's, they cancel out. Negative k equals 4. K equals negative 4. The opposite of the sign in here. Another way to even look at this deals with the shifting concept that we did before. Because x minus 2 is in parentheses, that's a left-right shift, opposite direction. So that's right 2. This is a little different though. Y plus 4, it's inside parentheses and it's a y variable. So it's the opposite direction of that variable. So this will be down 4. So that's the center, right 2, down 4. The last bit of information we need here is the r squared is equal to 9 over here. So r is 3. So we have our center and our radius, and that's all you need to graph a circle. So we will start by plotting the center, right 2, down 4. So this is the center, and the radius is 3. So we'll go 1, 2, 3 units to the right, 1, 2, 3 units up, plot a point there, 3 units left, and 3 units down. So you can do a quick sketch right here of the circle. So this point here in the center, it helps us with graphing the circle, but it's really not part of the actual graph itself because it's not on the outside circumference of the circle. So that's how you graph circles. Now we will take a look down here. We're going to write the standard form of the equation of a circle with the center given and the radius. So reversing the process. And we'll start out with writing out this general form of the equation of a circle. So all you need to do is, the center here is the HK. Just plug those numbers in for the H and the K, and the radius is 3. Plug that in over here. So here, if you need to show this, are the values for H, K, and R. But you do know that because this is a positive 4, inside it's going to be x minus 4. This is a negative 5, so when you finish this, it will be y plus 5. So here we're filling in the h value, so x minus 4 squared plus y minus the k value, which is negative 5. So when we and then out here we have our radius 3 squared. So when we simplify this, it'll be y plus 5 squared. And always multiply these exponents out, so 9. So this is the answer to the problem. If you were to graph this, again, you'd be going x direction, opposite way, so right 4, and y direction, opposite, because the plus 5 is inside, so this would be down 5. So that's right 4, down 5. and then do a radius of 3. So finishing up this topic, down at the bottom here are the few formulas that we learned here. The distance formula between 2 points is basically the Pythagorean theorem in disguise. And the standard form of an equation with center HK and radius R is right here, which again is Pythagorean theorem in disguise. Or your equation of a circle could simply be x squared plus y squared equals r squared if the center is at the origin. This means h and k are 0. So when you come in here and put zeros in there, you simply get the x squared and the y squared.